Okay. Hello, everyone. Welcome to our ANGS meetup. Today we have a Thomas Dewson talking about state machines in Angular. Thomas knows a lot about making websites with Angular and will teach us how to handle changes in our apps better. Get ready to learn something new and useful for your projects. Let's welcome Thomas. You can
Welcome,
start, Thomas.
everyone. Welcome, everyone, and thank you for the nice introduction. As mentioned, my name is Tomasz Ducin, and what I do is I do development architecture. My most two important tools are Angular and React. I used to be a development team member working since 2007, so that would be kind of 17 years so far, so that's quite a lot. So what I'm doing is I'm helping other teams in topics related to architecture, performance testing, um, micro front ends, whatever the teams could step upon and have any kind of difficulty. So I just help teams in achieving their goals. So as mentioned, Angular, React, but also things related to TypeScript, JavaScript, obviously, web performance topics, testing, unit testing, integration testing, E2E testing, etc., etc. So there is a lot of those topics that are within my area of interest. So one of the things that I consider the most important in front-end area that is, I would say, um, underused and should be way wider used is state machines. So let me do this kind of presentation. Well, actually, it's not going to be a presentation. I would like to actually make it a kind of slightly mix of live coding session and the discussion and reasoning, like what are the different factors that we should take into account, the advantages and disadvantages of when thinking about potentially applying state machines. So I would like to use to everybody a very simple and small repo with an application that we can see over here. So I would like to show you where do state machines apply, what issues do they solve, how can they be useful, how we can implement them, etc. This is going to be library agnostic. So the only thing that we are going to use is actually going to be pure TypeScript, of course, within on top of Angular. But no, third-party libraries that you might not be familiar with, or at least even if we mention them, that would be way later on our way. So, dear everybody, I would like to start with with what most of us usually have. So, the application that we've got here, dear everybody, is that we have just a simple CRUD application with lots of tabs. Here we've got like home, license, finances, offices, projects, employees, whatever. Let's say that this is a human resources application. So let's say we have a company that employs some consultants and that they send those consultants to work on some various projects. And here in the employees tab, we basically load some data from the external API, whatever that is. And what this external API displays is going to be, dear everybody, this employees listing component TS, and I'm going to open the corresponding HTML file over here. And one of the things that I would like to also mention is basically moving away from the old, let's say old, RxJS based components where we need to interact directly with streams within our templates and be more kind of modern in a way that we would be more future-proof and be consuming signals way more. So what we've got right now over here, dear everybody, is that we have in Engion init, we are instantiating what is our employee stream. So we've got basically an observable of employee array. An employee array basically is, as you can see, an entity that is being returned from the API. So you can imagine that this is just a list of employees that we are going to return. And that's basically those employees that we return over here. So that's one thing. Another thing is within our template, dear everybody, we are accessing the employees data through an async pipe. And we are using an alias over here so that there is employees dollar pipe async as employees. And using the ngIf, we're making sure that we can display whatever is the inner content of the div only if there is any truthy value within whatever async pipe has returned from us. Now, if you want to make this flow slightly more complex, then we could start getting into like slight trouble when we want to start managing our state locally. And that is, dear everybody, here we have so there is basically some IT corpus sidebar that we don't care. There is some span icon, don't care. H2, the header, don't care. And some city dropdown, like we could basically remove all this stuff so that it even doesn't bother us. So, dear everybody, what is the whole point of state machines? Right now, so put simply, the whole point of state machines is that we want to make it impossible, dear everybody, to walk into impossible states. So by the way, we can also start noting these things down. So we want to make a so-called impossible states impossible. So that's one thing. And so that basically means that we want to have type safety within our state data. That's one thing. Another thing is make sure that we can process only valid state transitions. And moreover, this is, well, not required, but this is going to be a very nice consequence, and that we do a design first approach. And that basically means that whenever we want to use something, display something, extend something, etc., then whatever we implement, there is some design. By design, I mean, whenever you want to implement something, first you have to think through it, like come up with an idea, like come up with a design, and then only you code the thing, right? If you try to do like a mixture of designing and implementing, this is sometimes kind of challenging because designing and thinking is very high level. You think about the issues, you think about the problems that you want to solve. And basically implementation is low level, basically coding. And for many people, it's basically difficult to switch between the high level thinking and the low level coding. Now, design first approach, basically, the whole point is to write down your ideas. What is the whole model that you're working with? And now, dear everybody, if we go back to our React component, right? The thing is, we are consuming the stream over here, right? Also, we are doing only one request over here. We can also take a look at the network tab, and I'll just refresh the page over here, and we can see that within this fetch slash xhr, except for geo, which is basically over here, it doesn't matter. We have only one request over here. So this is not very difficult. But if we introduce one more feature into this application, and that will be basically loading a multi-request collection over here, then it becomes challenging because we would need to maintain both what the state is, the data that we have loaded, whether we are during the loading state, or maybe there is an error. And if we take a look at a very simple data loading, the problem is, where is the design? And actually, currently, there is no design. So this is a problem. So what we want to do, first of all, is basically coming up with the design. And what I see very, very often, dear everybody, is that what people do is, if we want to have our state locally, so first of all, we could basically start consuming the stream from our template, and this is fine. unless we need to customize the things. For instance, if you want to display our loader, by the way, I think I have removed slightly too many things. Oh no, we haven't displayed the loader at all. So by the way, we have something that is called IT Corpo loader. And now, Copilot has suggested, because I'm using Copilot here, IT Corpo loader, Copilot has suggested what I could put over here, and it suggests, hey, use a loading stream, right? But I don't have the loading stream. So how could I do a loading stream? Now, dear everybody, this dot employees, I'll just open it in a side element over here. So this is basically a very simple service that is doing a very simple request, which is here is just get all employees. It just lies because it's just get page, which seems like just fetch the first page, right? So what is basically the first page apart from creating the query string is just doing http.get for just one simple URL, and that's basically it. So there is nothing more interesting. But let's assume that this would load the entire collection. And now the thing is, dear everybody, this is a cold stream. And this is going to make a side effect by running the request. And now the thing is, if I want to display the loader, right, I could go carry on with the stream API. But if I wanted also to display some kind of an error statement, div, let's say whatever that is, and let's just display an error over here. Now, again, either we display this as we use it as a stream, or if we don't use it as a stream, but just use as properties, right? Then we need to have those properties in the first place, right? So we could have a mixture of the, just static properties and the streams, but it's not very clean or clear, because if this is a stream, then why wouldn't we subscribe over here and just have all the properties? Like, why is not everything handled in that same way, right? So what I'm going to do right here, right now, is I'm going to provide a manual subscription so that everything what we have over here is just going to become, dear everybody, a property. So let's make it just is loading, which is going to be a Boolean property. We're just going to have an error message, which could be just an error, something that determines that, yes, there is some error over here. So let's just even make it error.message, or maybe you can just leave it as a string. So let's carry on. Is loading, which is going to be initially true. Next one, error, which could be either a string, or undefined. So if it's here, then we display it. If not, then we don't display it. So let's also put an ng if statement over here with the expression that is error. Later on, we will basically get rid of all these things and replace them with the new control flow and signals. But I just want to keep things simple for now. I'll just make sure that what we have over here compiles, and I probably have removed one curly braces too much. And there would be employees, so whatever the data is. And now, dear everybody, this is actually the beginning of the problem. So here, this is the before that I'm going to refactor. Now, why do I consider that this is a problem, right? Of course, like I would still need to get rid of these things over here, so that that would be employees as, actually, we don't need to do employees as employees because we have them. I'll just put that this dot employees, we'll just make a employees dot subscribe, and whenever we have the subscription, then yeah, this is what we need to do. So whenever there is some resulting data, the employees, what we want to do is we want to set whatever we've got over here. Yeah, so that would be more or less it. So we don't have yet the the error handling as for now yet. I'll just make sure that everything compiles over here. Yep, let's just see whether the app displays correctly. And it seems everything is okay. All right, so here we're already not using the pipe. We're not using the pipe, we're just using the properties. Now, this is something that doesn't have, dear everybody, that doesn't have state machines. So before we walk into state machines, let's see what is the problem that we're trying to solve. So first of all, dear everybody, we are starting with initial value of isLoading, which is true. Cool. Now, we don't have anything like a reload, but if we add something like a reload button, like there is a button reload, there is a click handler, and let's put that there is a reload function. Now we would have to reload, we would have to do it once again. Now, again, we would like to make it that this would be a long-lived stream, right? But I will just for the sake of simplicity, I would just ignore it just to keep things simple. So there would be this dot reload initially, and yeah, this way we have short-lived streams maybe, which is not the best way, but I would like to show you one more thing. For instance, when we initially load the component, the loader is here. Oh, by the way, I'm missing the label, obviously. So I'll just put the reload label on the button. And let's just see how this displays over here. So yeah, we've got the reload. So initially, the loader is here. But when I click reload, as you can see, the request goes here. But we have forgotten about setting up the loader. So let's add the loader. So let's get back to the repo over here. I'll just close the irrelevant one. So initially, we forgot to set this dot isLoading equals true. Now, what the problem is that we're starting to have is that there are three independent properties or three independent pieces of state, and we will have to support all of them explicitly. So now, dear everybody, let's take into account that something could go wrong. So we do a right click over here and let's block or unblock, like block request domain, and let's make sure that whatever we do over here, let's just, I'll just enable it. And I would like to, by the way, this is page 1, so let's block request URL. So in this case, whenever I want to load page number 1, and this is what we're actually loading, then we would get an error. As you can see, we're getting an error. So we have no, like this has been blocked. So for this reason, this is marked in red. So we have no error handling. So let's add error handling. What should we do, dear everybody, with the error handling? Most probably, we would like to use some stream, most probably. So by the way, this is created over here. So let's put a pipe. Let's put a retry operator. That would be, for instance, 2. And retry 2, what retry 2 is going to do is basically, we are doing a first attempt to load the data. If this one fails, then we are going to retry for the first time. If this one fails again, we're going to do a retry for the second time, right? Now, if still there is no success in our case, then we should, dear everybody, notify that there is some, error situation. So the subscribe that we are using over here is actually the subscribe of only the next notification. So let's replace this one with the more verbose API. So in case of the data, this is basically what we do. Now we don't use the complete one yet, doing nothing here, and let's use the error. So whenever there is an error that takes place over here, yeah, this is basically what I want to do now. So this dot error basically equals e.message. This is what we want to have. But again, as you can already imagine, the problem, dear everybody, is that if I'm setting the error over here, then most probably I should also clear the error over here. And the problem that we are kind of approaching is that this seems to be so simple. This is just 3 properties. But imagine, initially, we have to support these things. Moreover, when we get into the next, we also need to support the 2 properties. Now, when we walk to this.error, what else should we do here? We are initially in loading. So when the things go correctly, when things go fine, then we hide the loader, but also we should hide the loader when we walk into this state, right? And the problem is, again, dear everybody, we have a couple of states here. So there is some design, but where can we see it? That's the issue. There is nowhere when we can actually see like what was the idea behind the developer, right? So more or less, most often what people do is people, do everybody think of creating such data loading states as if there is basically a loading state, and there might be a success state, and there might be an error state. And that's absolutely like correct, valid, etc. But the thing is, where can we see this within the code? So this is a state machine. This is actually the simplest state machine that I could think of, right? But the problem is, to everybody, that there is no type that could actually guarantee what we are going to do. And what I mean by this, if we take a look back at what we've got over here, dear everybody, it is loading is true. How many values could we have within that property? Since this is a Boolean, of course, we could have 2 values, true or false. Now, if we have an error, which could be, we're displaying the string here, maybe we could switch it into an error. And in this case, if this is an error, we could go with error.message. I think it's going to be a better idea. So let's say that once. So let's simplify that either we have the error or not. Like, of course, we could have multiple messages, but that doesn't matter much. So either we have it or not. And in the case of employees, first of all, what the heck is this? Like, initial empty array. Like, what is an empty array? An empty array, for instance, if I was searching for people who have name like XYZ, I believe there is nobody who has an XYZ name. So if I was searching for such a thing, I would get a response from the server saying, hey, sorry, there are no people who have XYZ name. But this would be a response. And now, if we are initially starting the component, what is our initial value of the response? The thing is, dear everybody, we have no response initially. Like, we cannot pretend that there is an array. We have never got any response of it. And the problem is, how could you differentiate the state of initially having never any response and, for instance, getting a proper valid response from the server that is basically empty? For instance, people who have XYZ name. How could we differentiate that? In this case, we cannot. That's the problem. Now, dear everybody, you could say that, oh, so what we could do is basically we could switch it into an optional property, like to make it undefined. Well, this is better, but if we carry on in this way, then whenever we want to do any type of processing on employee, we would need to make an if statement to check whether this exists or not. But again, how many possible properties values do we have there? Again, either we do have the employees array or not. So that is 2 and 2 and 2. What is the total number of technically possible states? And as Copilot suggests, that's 2 multiplied by 2 multiplied by 2, which means basically 8. It's a Cartesian product. And the thing is, how many of them do make sense? If we take a look at here, 3, right? For instance, is it possible that loading is true, success has some data, and there is an error altogether? Logically, no, right? But is it possible to define such state here? Of course. And that's basically the entrance to the problem. This is the first step to the problem. So all in all, technically, there are 8 states possible, but only 3 make sense. So in other words, 5 states are, and this is what we call impossible states. And the problem is 5 is majority of 8, which basically means whenever we have properties that are independent on each other, then they do not add, they multiply like in a Cartesian product, and this number keeps on increasing very, very, very fast. And only some, some chosen pieces do make sense. And dear everybody, the problem over here is that the properties, the reason, the core of the problem is that the properties are independent. So we would say that the core of the problem is that properties are technically independent on each other. Now, dear everybody, how could we make them dependent? Basically, and what do I mean that they are independent? I mean that they are independent in a way that if we have a method, what I could do is that this dot is loading equals, for instance, true, and this dot error equals new error, whatever that is, whatever. And let's say this dot employees is, let's say, an array with some data. Like this state doesn't make sense. And the thing is, we made it possible, and we don't want that. Why is the problem actually a problem? Dear everybody, if you forget about one of the things, for instance, you forget about clearing the error, is it possible that somebody would forget to clear the error? Yes, very likely that the more complex the example is, the more probable it becomes that somebody at some point in time would actually forget to apply any of the kind of edge cases, right? So what is the whole idea that I would like to show you here? The idea, to everybody, is that we can basically take this one and walk into the playground, or maybe the other way around. I'll just copy the things from the playground and move them here so that we've got all our presentation notes over here. We want to make impossible states, like we want to make them truly impossible so that it will be technically impossible to create such state. Now, is it, dear everybody? So what I want to say, technically, it's impossible. Technically, it's possible to walk into an invalid state. What we want to do is we want to make it impossible on the type level thanks to TypeScript. Now, is loading true and error being an error is impossible. But is it possible that is loading is true and there is no error? Absolutely. And is loading true, no error, no data? Absolutely. Right? So we just need to list down what are the probable state combinations. And that's basically it. So we are going to, thanks to TypeScript, we are going to define what are the proper states and their corresponding data. But on a TypeScript level, we are not going to define what are the transitions between the between certain states. So what we need to do right now, dear everybody, is to replace whatever is here with basically a TypeScript-based union of object types. So all in all, let's say that there would be a type loading state, whatever that is. And now we don't want to create independent properties because that's the source of the problem because they multiply. So we want to create dependent properties. So for instance, if loading is here, by the way, we can start designing our idea. So first, loading, by the way, the convention is that we can just do loading with uppercase. Whenever we have loading, does the error exist? No, because we are loading. Does the data exist when we are loading? No, because still we are loading. We haven't received the data yet. So we have nothing apart from the loading. When there is an error, are we loading when it's an error? No. But also, when there is an error state, we should also include, so the payload of this one is actually the error, right? So the fact that there is an error, it implicitly means we are not loading. So we are not even including the is loading, because why would we? By the way, uh, this is a problem with booleans, but we'll get back to it. So loading, it basically means loading, no error, no data. So implicitly, no error, no data. In error state, we have the error, and implicitly there is no data. And finally, within the last one, there would be data loaded, or we can also call it success, whatever. And there is the data, which is basically employees, and there is no error. And the thing is, dear everybody, here, could we, with having, independent properties, could we define the array independently on whatever these are? Yes, because this is allowed. But here, could we, dear everybody, walk into the success state without declaring the data property? No, because this one is not optional. So this is either required or it doesn't exist, but it's never optional. So all in all, like there are some side notes that I want to emphasize. First, optional properties are not always, but quite often, a code smell and a side of and a sign of bad design. Why do I consider optional properties a sign of bad design? Because it's very easy, dear everybody, to introduce this one question mark without thinking through what should be allowed and what should not be allowed, right? That's basically one question mark. And whenever you'll be using this property, you always have to check within an if statement whether this exists or not. And actually, like the need to do the if statements is one thing, but also multiplying the states, this is the source of the problem. So I would say try to avoid optional properties as much as you can. So if you get something from the API and something is optional within the API, that's fine. If it's optional in the API, then most often there is nothing you can do about it. But don't include optional properties within your client-side model. So all in all, try to avoid optional properties within your client-side model, right? So try to include, if something is required, make it required. If something is should not be there, just don't include it there. Of course, you would need to use TypeScript unions in this case. So this is what we're going to do exactly. There is a state loading, but also I would like Copilot to make it an uppercase. So this could be a state loading. Here we would have the state error. By the way, I hope, yeah, it will guess what I want. So if I am in a state loading, it means I don't have the error and I don't have the data. When I'm in the state error, I have to have the error, otherwise it would be illogical. And the whole thing, dear everybody, is that we are not going to assign each property one by one, because this is very erroneous, right? This is vulnerable to errors. We're going to replace the entire object. So imagine this is super consistent, and this is imagine this is like a transaction. Either I replace everything or I replace nothing, but I move from one consistent state into another consistent state. How can I walk into an inconsistent state? If I don't hack TypeScript, I cannot. And that's basically the whole point, right? So this is state loading, this is state error with a required error, and here we'll have success with data, which is basically an employee. If we want to make it slightly more generic, then that's basically it. And or whatever, like with T, which extends basically that there should be some ID which is of type property key, whatever, or just ID, sorry, a number or string, that there is basically an ID, whatever. And dear everybody, the thing is, TypeScript doesn't know in which state we are right now, right? But like no matter in which state we are, there is nothing that is optional. And that's the whole point. So try to avoid optional states in your model as much as it's possible. Like you cannot avoid something, or you often cannot avoid something that comes from the API, the server API. So that's one good practice to follow. Another good practice that I would like to, or at least a problem that I would like to emphasize, is there everybody so-called Boolean obsession. So Boolean obsession is basically a kind of anti-pattern where people overuse Booleans. This might sound kind of, what the heck is this guy speaking about? So there is a kind of approach, a theory saying that we should avoid using Booleans entirely. Why is that? Because most often when you start with a Boolean value, sooner or later, you will end up in a situation when you don't have just two potential values, but you will have 3, 4, 5, etc. And the problem is, if you started with a Boolean value, most probably you will be using it in multiple places. And now what you should do when you find out you have more than two situations, but you have more, you should remove the Boolean, replace it with an enum. But hey, this costs me quite a lot, right? I would have to change multiple places. So what would a person do? Introduce a second Boolean or a third Boolean. And again, what is the consequence of that? That we again walk into impossible states. So that's again the same thing. So dear everybody, this is loading, which is Boolean. It has been wrong since the very beginning. Why? Because dear everybody, in this very simple loading example, we have three states: pending, loading, and pending, loading, the same one, success, and a failure, right? So why are we trying to represent a three value enum within a Boolean? And that's a problem. Like you could say, hey, but there are some situations where I'm absolutely sure I would have only two values. And I will prove you wrong. Like, what would be an example of something that would be always a Boolean? And somebody could say, hey, that might be a checkbox, right? A checkbox is basically something that would represent, well, that's either checked or not checked, right? But let's take a look at this checkbox, and there is something that is called exactly indeterminate. So let's take a look. What is indeterminate checkbox? So dear everybody, all in all, it happens that if we have, and that's basically like, this comes from CSS tricks, but that's basically something that is already in the DOM standard within the browsers, implemented already into your input type checkbox things. So, dear everybody, the problem is that we've got the checkbox which started with a checked attribute, true or false, right? But if we have nested checkboxes, and for instance, here with giants, Andre is checked and Paul Bunyan, sorry if I pronounce it in an incorrect way, then the Andre is checked, Paul is unchecked. So how about giants? It's neither checked or unchecked, it's indeterminate. So all in all, dear everybody, is a checkbox always a Boolean? No, not always. Often, but not always. And the problem is, if we started with a checked, which is a Boolean, now, how do you think? Would it be possible to refactor all inputs to make checked a num if millions of people are using it already? Of course not. We're going to introduce yet another attribute in determinate. So, dear everybody, we're just having two properties. And now, again, we're going into the same issue. Checked could have two values. Indeterminate could have two values. So we've got four values possible. Sorry for the animation on Zoom here. So we have four values. How many of them are possible? Three. Again, the very same problem. What should checked be? It should have never be a Boolean. So all in all, Boolean obsession is when people overuse Booleans, but actually, so when people overuse Booleans, but actually some people say that that we should always start with enums. Like, what is the issue when you start with an enum that has two values? I would say there is no issue, right? Whether it's true or false, or you at least could explicitly say what is, enum value 1, enum value 2. But enum can be extended and the Boolean cannot be, right? So that's the issue. Okay, so side note, optional properties. This is something that we want to avoid, especially the whole point of walking into state machines is that we want to avoid optional properties. Boolean obsession. Again, we want to avoid everybody introducing Booleans in our local model because they are not extendable. And the problem is, if your code base already depends on the Boolean, then most probably you would not refactor what you should do, but you would again introduce another Boolean and we walk into the same trouble over again. And finally, dear everybody, there is one more thing, and that is called primitive obsession. So primitive obsession basically means that we are using primitive values instead of objects that represent bigger things. For instance, a primitive obsession example would be that we have an var amount, which is, let's say, 100, and var currency would be, for instance, euro. This is an example of primitive obsession because what we should do instead is basically that we would have a cash or whatever money, an object that would represent the whole thing. And again, what is the point here? If I have separate values, properties, variables, whatever that is, could I just replace one amount from 100 to 150? Yes, I could. Now, is this allowed in my logic? Often not. Or could I replace euro with, I don't know, USD? Is it technically possible? Of course. Is it allowed? Not necessarily, right? So what we should do actually most often is that there would be either an interface, a class, or any other paradigm, functional closure, whatever. But the thing is, primitive obsession basically says that instead of going up with coming along with lots of primitives, what we should come along with instead is bring up something higher level instead of basically having, a bag of logically related but technically totally unrelated things. And this is exactly the point that we're having right now. So, dear everybody, what I would like to do here, by the way, let's check whether our piece of code works correctly. So we're going back to the bad approach, which probably works, but let's just take a look at this. So I'll just uncheck the error situation. Let's reload the thing. So it seems it's working right now. And just one more thing, when we have a retry, let's introduce an exponential back off so that whenever we have a by the way, when I have this retry, when I want to actually do the retry, then how fast would RxJS actually try to make a retry? How soon would it make the retry? Immediately. And that's the problem because it's not very convenient for me to try to make an error. For instance, if I just clear the request over here and I try to reload, as you can see, immediately I get all of the three. So if I just wanted to wait and uncheck this one, I don't have any opportunity to do this. So this is very inconvenient in development and, DX, debugging, etc. But this is also a very bad idea to have in your production environment. Why? Imagine you have an error, right? Somewhere. It could be an error in your network connection. So you're out of internet, for instance. And if you try to retry your request immediately, then it's not very probable that your connection would immediately be up, right? It would make sense to redo the request after a second, after 2 seconds, but not immediately. And take into account another situation. Your server is down, like throwing 500. Something is wrong on your on the side of the server. Now, if you again try to redo the request immediately, then this is like, it doesn't make sense, because if the server is down and other clients are also sending requests to the server, then what is going on? The server is down, and when the server wants to go up, it's being flooded, with tons of requests, and drowning in all the load and all the workload. So the whole point is we should just relax and give the server just a while to stand up, load its caches, basically, just have a while to breathe, to become stable, and only then to proceed. So for this reason, whenever you do a retry, try to make not an immediate retry. So by the way, what we have right here is an immediate retry. We don't want that. So that would be immediate retry. Often don't do this. It's a bad idea for both in production and in development, testing, etc. So what we want to do, everybody, is we want to provide a configuration object. So what we've got over here is, let's say we still want to have 2 retries at most, but there would be also one more property here that is going to be, what is the delay? So if we provide that the delay is 1 second each time, then this is not an exponential backoff. This is actually, dear everybody, a linear backoff. So we don't want that. But that would still make more, that would already make more sense, because the server or us, the developers, could at least, have a little bit of time to react to make something better. So if we start with something that is locked and we reload, then I have 1 second between each of them. So let's just start with the reload. And now I'm unchecking and I can, interact with it. And the server in the runtime could also interact and, make things better. By the way, have you seen that our application is actually messed up? Because once I have loaded the data, so there was a success. And now, dear everybody, if I make a reload and I will have a failure and one more failure and one more failure, why do I display the data? There were 3 failures, right? Why is the data over here? I have left it deliberately. So most often, whenever you start reloading, you should basically clear the data that you have displayed, because you are reloading it because most probably either the user or the application considers it to be out of date. So what we should do, actually, to everybody, is that when we start reloading, right? Or basically, even if the error was not here, during the time of reload, most often we want to hide the data over here. What is the problem? We haven't cleared this dot employees. We haven't cleared the data. Again, if we were using state machines, the problem would not be there, which we will see in just a while. All right, so this is a linear backoff, and we want to create an exponential backoff finally. So let me just get rid of this line. And what we want delay to become is, dear everybody, as you can see, there is a delay which accepts an error and retry count. And that's basically what we've got over here. So error delay, give me a while. Delay is going to just let me take a look at the retry. So there would be a function that returns an observable. So error is basically whatever, and retry count is this one. So what we need to return from here is basically a timer from RxJS, and that's basically the thing. So we need a error and the retry count. Now, what could the error be? As we have seen in the type declarations, that could be basically anything, whatever the error is, and retry count is going to be a number. Now, how to make the error exponential? Basically, we need to make sure that there would be the time that we're waiting here for would be, let's say that we'll be using, this is in milliseconds. So if you want to have, let's say 1 second, then 2 seconds, then 4 seconds, 8 seconds, etc., then we would need to do that. There would be 1 second multiplied by, and here comes, dear everybody, the factor, which is basically the const delay, and that would be exactly 1 second multiplied by 2 to the power of retry count, so we can make it slightly more modern JavaScript in that manner, and that would be basically, yep, that would be it. Of course, we could basically put it into a single expression. So in this case, the first retry is going to be 1 second, the second retry is going to be 2 seconds, 4 seconds, etc. And this is what what I would suggest everybody to do. Also, we have cleared the employees list over here, something that we have forgotten about. So, to everybody, let's start once again. We're going to start with an error. The second attempt is an error, but the third attempt would be a success. But we have to wait 4 seconds for this, and it succeeded. Now, if we try to reload, then we have already created the clearing, right? And let me just go back once again. I'll just put the reload up just above the ng on init so that we can see all of them, dear everybody, at the same time. So we've got the reload over here. Again, going back to state machines. The problem is that they are independent on each other. So what we should do, dear everybody, we're just going to use the loading state over here. So we are removing the whatever is the before. Oh, by the way, I'll move the side note also upstairs over here. So we're just going to replace what we've had before with what we have after, and that would be the state machine. And let's remove this one, and let's call it, let's say, loading state, whatever we call it. And loading state is going to be, of course, loading state of state loading, right? And we are going to replace the objects. And as mentioned, dear everybody, could we create something like this? Error of type new error, whatever that is. This is a correct error. Now it will say, hey, like TypeScript will say, hey, dude, like if you're in state loading, you cannot put additional properties, and this is called excessive properties. So from polymorphic point of view, it would be possible, though, when creating literals, including objects, TypeScript disallows to create excessive properties, and thankfully it does, because most often this is a sign of an error. So basically, I cannot put excessive data, which is very good, which is highly expected. Now, if you wanted to go into a different direction, and that would be, let's say, create an error state. So this is fine because error is expected. But if I forgot to put whatever is expected here, then TypeScript would say, hey, property error is missing in type. And dear everybody, as you can see, type-wise, our state machine is as bulletproof as our state design. So if our state design is, well thought, well considered, so would be our state machine, right? So excessive properties throw errors, missing properties throw errors, which is absolutely awesome. And one more benefit that we have, I mentioned that starting, dear everybody, with a array, an empty array, is a very bad idea, because we couldn't distinguish an array being the initial state from the array being a empty response from the server, right? And because we had to, come up in some way with what is going to be the initial value. Now, dear everybody, what is going to be the initial value if we are in the loading state? The problem doesn't exist here. Why doesn't the problem exist? Because if we are in the loading state initially, then employees themselves, they don't exist yet. So we don't have to initialize the property if it doesn't exist yet, right? When would it exist? Well, when the data arrives. But when the data arrives, we're going to replace the entire object with the success state or whatever we call it, right? But then we'll guarantee that the data has to exist. Otherwise, TypeScript would not allow us to walk into the state, to transition to the state, which is absolutely like, this is very clear, but it's also, if you think about it, like, it's so clear. This is like, I find it very attractive that this is so clear. By the way, if somebody was told that, hey, you're not just going to load the first page, you need to load, I know, all of the pages of the collection, and you would have not only the state of loading, you would not only have the state of being inside an error state, like this one that we will see in just a while, like this one, but you could all, and of course the data success, as we can see right now, but you could also be in the initial state, success state, error state, the ones that we have already, but you could also be in the loading in progress state, meaning you have already loaded the first page, but you're still waiting for the other pages to load. There would be a fourth state, for instance. And the thing is, such a person, given such a task, comes into this component, this file, whatever, and what the person can see is, hey, okay, so this is the design that the previous developer has left. So now, okay, here, you're just saying that this is an initial state, right? Here, if you're in error state, you need to have an error. Now, if you have the data success, this means you're not loading anymore. So probably I would need to provide like loading in progress, whatever we call it, loading in progress, which means you have already loaded some stuff, but at the same time, you're still loading. If I want to show the loader, I would show the loader in both loading state and loading in progress. And when I want to show the data, I would do it in both success and loading in progress, right? That makes sense. And now what is important? If you walk into such a file or such a component, such a service, wherever you put it, what was the idea of the developer who started doing that? You can see the design. Design becomes the first-class citizen, a first-class citizen of a system. Without the whole idea, the whole concept, what did you have before? Just a piece of variables that are unrelated, technically, unrelated to each other. This is so wrong, right? So you would like to have a, you know, like, what are the allowed combinations? Okay, so dear everybody, what we have right now is, of course, our application is crashing because Angular compiler cannot see what are the allowed values over here. So what we're going to do is, again, there was a lot of clearing over here and over here and over here. So I'll just leave this reload with primitive approach so that we can later compare how ugly, how bad it was. And I'm just going to provide the new approach with this reload function. So whenever, by the way, when do we run these three lines? Whenever we want to reload, either initially or whenever we click the reload button. So what we want to do is we want to set the loading state right here. What is the loading state? This is the initial state. That's so clear, right? Now, when we get the next, meaning, okay, here is your next page, whatever that is, what we want to do right here, right now, is basically, I'm deliberately writing this as a one-liner, is that this loading state is basically a success. What is your data? Basically, whatever you've got from the API, right? And when we've got the error, again, what are we going to do right now is that this dot loading state is basically the error. That's it, right? So, right, we're not using the complete yet. Maybe we will. Of course, I need to comment this one out, and I'll need to update the template as well. But I hope you can see that we are not working with primitive properties, with explicit properties. We are working with objects. And whenever we change something, dear everybody, we have to replace an object with a separate object. This way, we solve two out of three problems that we have whenever we don't use state machines. So the problem number one, we are so the goals that we had. So type safety within our state data. So this is, dear everybody, checked, because what we've seen, we cannot put excessive properties, we cannot forget about required properties, so this problem is not here. Design first approach, write down your ideas. So the design is a first-class citizen of the system. So this is already checked. Now, something that is not checked on the TypeScript level, and well, theoretically it is doable, though this would require quite significant lot of amount of coding, is what are the valid transitions. So all in all, dear everybody, if we take a look at the transitions, we can see that we can move from loading to success, and we can move from success to loading, and we can move from loading to error and from error to loading. But it's impossible to move from success to error and vice versa from error to success. Now, does TypeScript check which transitions are valid? Unfortunately not, because if we just have a union of object types, then only the data is being checked, but not the transitions. So what we could do is potentially, there would be, let's say, move to, let's say, not move to next state. That would be move to error, right? And that would be basically a function, right? Or we could put like, reload, and that would be, yeah, like, move to error is okay when we're loading, but like, from where could you move to the error? Only from loading, right? And how could you walk into the loading state? You could reload while being in error state and while being in success state, right? But you cannot reload while you're loading because it doesn't make sense. Like, well, you could theoretically add it, but it doesn't make much sense. But again, where could you move into the error state? To everybody, only from loading. By the way, when you move to the error, you have to pass what the error is. And now, is this like making sure that only the valid transitions are here? Is it possible on a type level? Yes, but I would say this is not very useful, I would say. So I'm just going to remove it. So the alternative that we can carry on with is that we would do transitions, like checking the transitions in the runtime. So whenever we actually want to do the transitions, we would basically do an if statement on the JavaScript level, and whenever something is wrong, basically a error would be thrown, or the thing would be ignored, like if something is incorrect. But I would say, like, I'm a fan of fail fast. So whenever there is a potential error, don't let if there is a mutant, don't let the mutant, do the nasty stuff. If something is a potential error, kill the mutant. Like, don't allow the error to spread across your application. If something is not trustworthy, kill it, destroy it. Because like, if you cannot trust something, like, don't rely on it, don't deploy it, right? Better to step back, think about, okay, what is wrong with my design, right? That, I would say, this is the right thing. So again, dear everybody, this is doable, but whenever we move from one state to the other, right, as we are doing here, we would have to create these callbacks. And this is what I want to avoid, because this is not very convenient. So that's basically the thing. So, dear everybody, we have updated the reload thing, but we haven't updated yet our template. So basically, what we want to check over here is whether our ngIf is in state loading. So we would just need to check whether our loading state, dear everybody, whether our loading state equals loading. That's basically the thing, right? That's the thing. Now, another thing that we could do is, oh, by the way, it says ngIf on the state error. So, dear everybody, the thing is, we could check whatever is the state, right? And now I'm deliberately not writing the double equal or triple equal, whatever that is. It doesn't matter much. But the thing is, it says that, oh, by the way, what I want to do is not the error message, but loading state dot error dot message. And I would like us to focus, because this is very important on Angular level, to focus on these two lines over here. Now, if I do an ngIf over this one, then what happens underneath is that TypeScript will check, and Angular compiler relies on TypeScript compiler. This is very important to note. We have three possible situations in our state. So this is either loading or error or success, right? Now, in case of loading, we have no properties that we would like to access additionally. But in case of error, there is. We want to access the error. And now, dear everybody, this is our HTML, let's say, top level. So by top level, I mean there is no ngIf that would be on top of that. So what is our ngIf checking? Actually, this is checking whether state exists or whether it's just truthy, right? Because I haven't put the equal, equal, equal. And what TypeScript compiler propagates to Angular compiler is that, hey, dude, you are of the type loading state employee. So that could be either of the three. Now, in which are you in? I don't know. So does error exist? Well, error does exist on one of them, true, but it doesn't exist on the other ones. Now, do I know in which one you are? I don't know. And this is what the error says. Property error does not exist type on loading state. And why does it include all the error states? Because we haven't done this one, and we are going to obviously do it. So there is at least one state of the member of the union which doesn't include the property. So all in all, that's quite a mouthful. But what we should do is basically check whether we are in the proper thing, in the proper state or not, right? And this is absolutely awesome that Angular compiler is using TypeScript compiler underneath in such a seamless way. And everybody, loading state, like outside, the loading state could be any of the three. But once we walk, like once we pass through the if statement, loading state is not any of the three. Like what could be the error as the loading state if state is an error? Well, it could be only the one. Is TypeScript aware of that? Of course it is. And for this reason, it will allow us to walk into it. Again, what we're going to do here is not an ngIf with employees which don't exist yet. We're just going to check whether the employee state is going to be what we expect, and that is basically, or maybe not go this way, loading state equals, what was that? Success? I believe I made a typo over here. Right. So what is employees right now? In our case, that would be loading state dot, we called it data, right? So that's basically the thing. And again, we've got the loading state dot data over here. And dear everybody, let's take a look at the error messages that we've got here. Oh, it says that there is a throw new error, of course, because this method here doesn't make sense anymore. So I'm going to drop it as well. So let's just make sure that the application compiles and we've got everything up and running. Right. So, dear everybody, the application compiles and I would like to break something. So let's say, dear everybody, that I will move to the error over here back again so that I will make an improper check. And let's see what the compiler error is going to be. And it will basically propagate the error of TypeScript compiler. Property error doesn't exist on type loading state, blah, blah, blah. Property error does not exist on type loading. So Angular compiler is basically propagating what we've got on the TypeScript level. So this is very, very important that using state machines, actually, like what I want to say is that we want the compiler to highlight all these errors, right? So as you can see, Angular compiler is capable of figuring out all things that are related to TypeScript within the directive-based ngIf, ngFor, ngSwitch, ngCase, etc., which is absolutely awesome, right? And if we move away from ngIf into the new, Angular control flow syntax, and we'll just put what is the, oh, by the way, maybe I'll just, for the sake of readability, I would just leave it like this. I'll remove the ngIf statement and put the ngIf over here. So this is absolutely like up and running. And as we can see in the background, the loader has been displayed over here, but still we don't need any additional properties over here. So we can do the very same thing with the error if statement. So let's create another if statement here. And what we're interested in is checking whether loading exists here. And let's drop the old ngIf directive and let's put the requirement over here. So again, this works, but you could say, hey, but I cannot see whether it works correctly or not. So let's again reintroduce the error, right? And as you can see, TypeScript propagates the error onto Angular compiler, which throws the exact same error. So all in all, what we've got here, dear everybody, is that this is bulletproof. Like, I cannot display the error message if I don't make sure that I am in a certain proper, error. And let's just move to the new syntax here as well. So I'll just replace it like this. But yeah, this is going to be the very same way that the very same thing that we've done previously. By the way, the difference between the directives and the new control flow is that it used to be a directive that is executed in the runtime. Now, the new control flow is a part of the compiler. So this is being compiled, so the directive doesn't have to be executed in the runtime. Like the consequence of whatever the if or ngFor or the for or etc. they're doing, they're bundled into the yeah, they're bundled. So there's no need to calculate it in runtime. There is basically executed in it's basically faster. So yeah, that's the whole idea behind it. So what we could do actually is I'll just make a quick, since we have still a quarter, we can just walk into the employee service and I would just pretend that we would have multiple pages being loaded. So this is just, I'm just going to pretend that we would have a multi-page loading. So what we could do here is that we would return a merge of an RxJS. And what we're going to merge over here is we would have the page one with the criteria. So what I'm interested in is I want this to be page one. I want this to be page two, page three, page four. Of course, I would not do it this way, but I would dynamically check what is the number of pages, etc. Like, let's just keep this for simplicity. And whenever we've got the data, of course, I don't want the next page to override the previous page because it doesn't make sense. So as you can see right now, if I click reload, it's first of all, it's random, which page is going to be the first one, which is going to be the last one. So we don't want that. And apart from that, we want the pages to accumulate. So all in all, we just need a scan operator, which would basically do the job. So we just need a scan exactly, which would accumulate the pages. So now we are losing the order in which the responses come back, but at least we are accumulating the pages. And dear everybody, what is going on right now? And I would like to slightly maybe using the network throttling to make it fast 3G. Let's see whether this helps. So what I would like to do is to see what is going on with the spinner. Let's reload. So as you could see, the loader is displayed only before the first response, but between the first response and the second, the third, and the fourth, the loader should still be there, right? Because we already have some data, but we haven't finished the whole thing, right? So we're getting back to the idea that I mentioned over here, right? So that there is a loading in progress. So that means basically we have some data already, but we're still loading the rest of the data. And what I think is absolutely awesome about this approach is that, yeah, we do have the design. So even if I mess up with the implementation, dear everybody, anybody else like me or somebody else from my team, somebody could see what was the idea. So I can validate whether the idea is correct, but the implementation is wrong, or maybe the whole idea is wrong. If I don't have the design, like everything is like, rubbish. Imagine improving this approach. And imagine that data loading is actually the simplest possible example of state machines. And you could have something which is way, way, way more complex. So, dear everybody, what we should do in this case is that initially loading is there, right? And by the way, maybe I'll just open the employee. Oh, by the way, one thing. This is our new design. And as mentioned, when should we display the error? Sorry, not the error. When should we display the loading thing? Where? Either when we are in the loading state or when we are in the loading in progress. And the thing is, when we have, when we have, dear everybody, a design, which is in this case a state machine, but when we have a design, we can split the work into doing the template and doing the logic. You could say, hey, I could also do the same thing, just having properties. Yes, but in that case, you could also access things that don't exist, which is a problem. So all in all, we want to display the loader when we are in loading state or we are in loading in progress. So what we can do is basically to replace, like I could, carry on with this one. Yeah, I could do it, but it's not loading. It's basically loading, loading in progress. So of course we could replace it. With an array.includes, whether it includes the loading state, or we could also come up with a method which would be probably more expected. So what the method would be to display loader, for instance. And dear everybody, if we return what we've got here, because I can understand that some people would say, hey, this looks so ugly, like there is logic in my template. I agree, this doesn't look very good. So what we could return from here would be this.loading state and this.loading state, right? And what I mentioned by the array.includes, that would be that loading and loading in progress includes this.loading.state, which actually, like, maybe this is not very way shorter. This is slightly shorter, but if you wanted to include, the third and the fourth, etc., then we don't, carry on with the rubbish approach. Anyway, this will not work correct because what we're returning here is a boolean. So whenever you work with state machines, you need to watch out for what TypeScript is capable of. So when we replace it with the display loader one, this is going to work, right? But that's only because we are not making any kind of type narrowing. So from the 4 branches, we are not narrowing to anything because the loader doesn't require any data. But if we have the display error thing, and we will return this loading equals display loading state equals error, and you wanted to apply the same thing, then you'll see that it will not work. Why? Because TypeScript returns a boolean. over here by the default, and this is the source of the problem. Of course, we can fix it, but as you can see, TypeScript cannot figure out that the error is here. Why? Because when TypeScript is doing this one, this one directly, then it basically means how many possibilities do we have here? How many branches? 4. So in how many of them do have the state equals error? That's only one of them, right? So if you want to walk into the state, you have to be in exactly this state, right? So TypeScript can see it. Now, if we move into this one, and we will see that there is a display error that returns a boolean, right? Then TypeScript cannot see where it comes from, right? And when TypeScript can see it, oh, if this thing is a boolean. So what TypeScript can see is that it's either true or false. Can TypeScript see from this declaration that there is any kind of relation to the loading state property? No. And that's the reason for the error. So dear everybody, when we have this thing, we would need to actually make it a type guard, custom type guard, saying that, dear everybody, what we've got over here with the loading state, so that would be this dot loading state, and there comes a problem because this is basically, dear everybody, a property on a class. We would need to say that the argument, whatever this is of a certain type, right? So this would be the thing, right? But we need to say, what is this? And we would need to say that this is this dot loading state. So this is doable, though this would be slightly more challenging to implement in an object-oriented manner. This would be very, very simple if we just passed it via an argument, because we could basically relate to whatever the argument. And here we would have state of the loading state over here, loading state. And since this needs to be a generic, we would also need to put the generic over here. And it would require us to satisfy the constraint. So that would be a little bit of work required here. So just to make it simple, or we could basically remove the constraint, and we would also remove the constraint over here, again, just to keep things simple. So this would work, as you can see, but we would need to, this is troublesome when we want to narrow down to properties on the object that we are on. So all in all, dear everybody, I'm just going to remain it to as it is right now. And here we can do the same trick with just providing the either this is a success or this is the loading in success with warning. No, this is the loading in progress, right? But again, oh, by the way, what we could see, what we could do to everybody is we could move it away into a class so that basically this loading state is not a property, not just a property with methods on the component. Somebody would say, hey, this should be a service. I would say, I would make one further step. This should be a signal that has computed values that relate to whatever the loading state is. So we'll probably not have time to do it, but once we kind of detach ourselves from this class, the problem is gone. And that's basically it. Because here we could make the assertion not on the parameter, but on this, right? But the problem is this, in this case, is the whole component. And if this was a signal, a class that represents a signal, whatever, then we could make the type assertion using the whole class, which would not be a problem anymore, right? So here we are in the loading state, right? So the last thing that we're going to do is loading, error, and success. They are as they were. There is the loading in progress one. So now when we go back over here to everybody, then we have initially we are putting the loading, and the issue that we had before was that we've been putting the success over here on each, dear everybody, next. Now, success means that we have finished doing everything. But how many next notifications are we going to have? If we take a look at employee service, we will have more than one, right? In this case, 4, but it doesn't matter. Let's say we would have 50 of them. So we would claim that we have already achieved success after the first one, which is not true. So what we're going to do, dear everybody, is that we're going to put the loading in progress one. So what are the employees? Well, the employees is what we've got here. Now, what does the next notification carry? It carries, dear everybody, the accumulated thing, because this is what our service, reactive service, is providing. Now, when we're done with everything, what would we do? We would need to make it complete, right? And now, the problem is, dear everybody, that we have to deal with, and this is the very last thing that we will do. So error is what we want. Initial loading is what we want. The next, which is loading in progress, is what we want. And finally, TypeScript says that, hey, dude, you cannot access whatever the loading state.data is. This is the very last thing that we will do because it's already an hour and a half. So I'll just break it into more lines just to make it clearer. But again, like as you can see, each time we are doing it as a transaction. So what issues does TypeScript have with that? So whenever we walk into complete, we know that how could we walk into the complete, the success state, the one that is finished? So in our case, this is, dear everybody, the graph of what was happening, the graph of the states. So from loading, we can walk into the error, and basically with the reload, we can go back to the loading. Now, when we start loading, we walk into the loading in progress state. Now, when we load new pages, we basically walk in cycles. So from loading in progress, we move to loading in progress again, which is what we're doing. We're transitions within this state, of course. And once the very last response is done, then we walk into the success state. Of course, from success, we can walk back to the reload. We can walk into reload back from in progress, etc., etc. And the thing is, dear everybody, when we want to move into the loading, the success state, the thing is, here we are moving from loading in progress into success. And the thing is, we are not on complete. As you might know, on complete, oh, by the way, as you can see, with complete without any parameters works correctly. But if I try to put any parameter, TypeScript fails. Why? Because the complete notification in RxJS doesn't include any data. So next includes the data, error includes the error, and complete has no parameters because there is no value for a completion. Complete only tells us, hey, dude, you have completed. So now, if you want to move from loading into progress, then we don't have this data. We have to borrow the data and copy it back from loading in progress into success. And now the thing is, can TypeScript be sure that we do have the data over here? And what are the possible branches? There are 4. So there could be state loading, error, success, and loading in progress. If we were in loading in progress, do we have data? Yes. In success, do we have data? Yes. In error, do we have data? No. In loading, do we have data? No. So what is the issue there, everybody? TypeScript doesn't know whether we are in one of the states that does have the data. So to everybody, what should happen here is actually we should make a check in which state we are. So what we expect that what is the state that we are in is we expect certainly that we are in the loading in progress state, of course. So if we are inside of that, basically we know that the data is there. But the thing is, what do we do in the else state, statement, the else part? And the thing is, dear everybody, that depends on your design. And either you can make a silent fail, which basically means do nothing, ignore, or I would rather say this would make more sense to throw a new error, because if there is again, as I said before, if there is a mutant, kill the mutant. So possible state, but I would rather say that there is an impossible state transition that would say from, no, that it would be impossible state transition into the new state, which is basically this loading state exactly. So I was trying to walk from this state into the state of success. So this would be one way to tackle this one. And the very last thing, I would actually like to reverse the thing. So if the state is not loading in progress, I would throw the error, and that's basically it. Of course, if we wanted to make it shorter, then we could come up with what is called a TypeScript assertion function that would basically look like this. Assert state. Now we make the assertion depending on whatever the loading state is and what we expect that the state is, and that is basically loading in progress. So that would be a assertion function. In very short, is a function, dear everybody, that have some params, of course, and it says asserts, and then no, asserts state is, and here comes the type. So it's basically the same as the type guard, but it also has the asserts, and it conditionally throws errors, which is basically what we've got right now. So this is a silent fail, and this is basically a fail fast approach. So if there is a situation which could be an error, it's better basically to throw it, because if I throw it, and if I push the code, and if somebody else from my team pulls the code and wants to use it, then what is the consequence? People will start, like, people will have to, the whole team will have to deal with the error. Like, they cannot, ignore it, right? So that's the whole thing. So just to recap everything that we've done during our session right now. So the implementation of a simple state machine actually relies on TypeScript unions. So basically, you just need to create a union of objects. In each object, you would need to have a property that exists on all of them. And what is important? Try to avoid Boolean properties, try to avoid optional properties. And the whole point that we're making those restrictions is that we make impossible states or invalid states impossible, that we cannot mess up with our state. And the design of our state management becomes explicit. We can see it, we can modify it. And also, thanks to the fact we can independently work on our view, and we can also work independently on our like data loading solution, whether this is RxJS or we are using, let's say, toSignal coming from Angular that will basically dump a observable into a signal. So what we would do, we won't, but what we would do is changing this one into a signal and providing computed values with the things that I mentioned being TypeScript type guards. So that would be just a small addition over here, but I think you do get the idea. So that's all from me, and thank you very much for listening and watching.
Okay, thank you, Thomas, for reaching us about state machine in Angular today. And thank you to all of you for joining us online. I hope you learned something useful that you can try in your own work. Keep practicing what we talked about today, and don't forget to look out for our next meetup. It's great learning together. See you next time.
See you. I think